Ever wondered how that silky smooth scarf around your neck was made? In the next 10 minutes, we're going to show you exactly how it goes from worm to wardrobe. We'll take you inside a Chinese silk farm where billions of silkworms are bred, fed, and harvested. You'll see the scientific selection of eggs, the massive mulberry farms that feed the hungry caterpillars, into fine threads. By the end, you'll never look at silk the same way again. A single gram of silkworm eggs contains over 1,000 potential silk producers. This tiny package holds immense potential, and it's where our journey into the world of silk production begins. In a sterile laboratory, scientists peer through microscopes, carefully examining these minuscule eggs. Their work is meticulous and crucial, as the quality of these eggs will determine the success of the entire silk production process. Selecting the right eggs is no simple task. Scientists face numerous challenges in identifying eggs with optimal traits. They're looking for eggs that will hatch into silkworms, capable of producing the finest, strongest silk fibers. This requires a deep understanding of silkworm genetics and the factors that influence silk quality. Genetic markers play a significant role in determining the potential of each egg. Scientists analyze various genetic factors, including those responsible for silk protein production, disease resistance, and growth rate. They're searching for eggs that carry the best combination of these traits, as they'll lead to silkworms that not only produce high-quality silk, but are also more likely to survive the rearing process. To aid in this complex selection process, laboratories employ advanced technologies. High-resolution imaging systems capture detailed pictures of each egg, allowing scientists to examine their size, shape, and color, all indicators of potential quality. Spectroscopy techniques help analyze the chemical composition of the eggshells, providing insights into the health and potential of the developing silkworm inside. But why is this egg selection process so important? The answer lies in its far-reaching impact on the entire silk production chain. Eggs with superior genetics lead to healthier silkworms that consume mulberry leaves more efficiently. These silkworms, in turn, produce cocoons with longer, stronger silk fibers. This results in raw silk that's easier to process and weave into high-quality fabrics. Moreover, selecting eggs with genes for disease resistance can significantly reduce losses during the rearing process. This increases overall productivity and ensures a more consistent supply of high-quality cocoons for silk production. As we move from the laboratory to the next stage of silk production, keep in mind the critical role these tiny eggs play. The careful selection process we've witnessed here sets the foundation for everything that follows. In our next segment, we'll explore the vast mulberry farms that feed these carefully selected silkworms, supporting their growth from microscopic eggs to voracious leaf-eating machines. From microscopic egg to silk-spinning powerhouse, silkworms undergo an incredible transformation. But there's a catch: their voracious appetite. What if I told you that meeting this hunger requires farming on a scale that's reshaping agriculture? As we step out of the laboratory and into the vast expanse of mulberry farms, the sheer scale of silk production becomes apparent. These lush green fields stretch as far as the eye can see, dedicated solely to feeding billions of hungry silkworms. It's a sight that truly puts into perspective the enormous appetite of these tiny creatures. Silkworms are nature's eating machines, consuming their entire body weight in mulberry leaves every single day. This insatiable hunger drives the need for extensive mulberry cultivation, transforming landscapes to meet the demands of silk production. Farmers must maintain a constant supply of fresh leaves to support the rapid growth of silkworms throughout their life cycle. However, growing mulberry leaves at this scale is no simple task. Farmers face significant challenges in maintaining ideal conditions for both the trees and the silkworms. The soil pH must be carefully balanced and the growing environment kept meticulously clean to promote healthy leaf growth and prevent disease. Many farmers resort to using lime powder to disinfect silkworm breeding areas, adding another layer of complexity to their already demanding work. The quality of mulberry leaves directly impacts the quality of silk produced. Healthier, more nutritious leaves lead to stronger, more resilient silkworms, which in turn spin higher quality silk. This direct relationship between leaf and silk quality puts immense pressure on farmers to cultivate the best possible mulberry crops. Harvesting and preparing mulberry leaves is a labor-intensive process that requires constant attention. Farmers must chop the leaves into small, manageable pieces and feed them to the silkworms continuously. This demanding schedule ensures the silkworms receive adequate nutrition throughout their growth stages, but it also means long hours and hard work for the farmers. As market demand for silk continues to grow, mulberry farming has evolved to incorporate modern agricultural techniques. New technologies are being implemented to optimize feeding and care practices for silkworms, improving both the quality and efficiency of silk production. These advancements are crucial in meeting the increasing global appetite for silk products. However, the future of mulberry farming faces an unexpected threat: climate change. Shifting weather patterns and extreme conditions are affecting the growth and yield of mulberry trees, potentially disrupting the delicate balance of silk production. This challenge highlights the interconnectedness of agriculture, climate, and luxury goods production. As we wrap up our exploration of these vast mulberry farms, we've seen how the simple act of feeding silkworms drives an entire agricultural industry. But the journey of our silk thread is far from over. Next, we'll step inside the controlled environment of silkworm rearing facilities, where these leaf-munching larvae transform into skilled silk producers. You might think that after leaving the mulberry farms, we'd see less impressive numbers. But what if I told you that the next stage of silk production involves managing populations larger than most cities? Welcome to the world of silkworm rearing facilities, where millions of tiny lives hang in the balance of precise environmental control. Stepping into a silkworm rearing facility is like entering a different world. The air feels different, carefully regulated to maintain a constant temperature between 25 to 28 degrees Celsius. Humidity levels are kept at a precise 60% to 80%, creating an atmosphere that's perfect for silkworm growth, but might feel a bit sticky to human visitors. The lighting is also meticulously controlled, providing the ideal conditions for these industrious insects to thrive. This controlled environment is crucial because silkworms are incredibly sensitive creatures. Even small fluctuations in temperature or humidity can have dramatic effects on their health and productivity. Maintaining this delicate balance is a constant challenge for facility managers, who must monitor conditions around the clock to ensure optimal silkworm health. As we move through the facility, we can observe silkworms at various stages of growth. Each stage has its own specific needs, from the tiny, newly hatched larvae that require tender young mulberry leaves to the larger, more voracious later-stage caterpillars that consume vast quantities of mature leaves. The care and feeding of these different groups is a complex logistical operation, requiring precise timing and attention to detail. One of the most striking features of these facilities is the rigorous cleaning and disease prevention protocols. Workers diligently clean the rearing areas, using lime powder to disinfect surfaces and prevent the spread of bacterial and fungal diseases. These diseases can devastate silkworm populations, so preventing outbreaks is a top priority. As we near the end of our tour, we come to the most fascinating part of the facility, the area where silkworms prepare to spin their cocoons. Here, we see large, square wooden frames set up to provide a stable environment for the silkworms during this critical stage. The anticipation is palpable as we watch the mature caterpillars begin to search for suitable spots to start their silk production. The impact of modern technology on silkworm rearing is evident throughout the facility. Automated feeding systems help ensure consistent nutrition, while advanced environmental controls maintain ideal conditions with greater precision than ever before. These technological advancements have significantly improved silkworm survival rates, allowing for more efficient and productive silk farming. As we conclude our visit to the rearing facility, we're left in awe of the intricate processes involved in bringing millions of silkworms from egg to cocoon spinning maturity. But the journey isn't over yet. In our next segment, we'll explore the fascinating process of cocoon formation, where these industrious insects showcase their true silk spinning prowess. Imagine creating a house entirely from a single strand produced by your own body. Sounds impossible, right? Yet this is exactly what silkworms achieve. As we delve into the art of cocoon formation, we'll discover how these tiny creatures perform a feat that puts human engineering to shame. When a silkworm reaches maturity, it begins an extraordinary process. The insect produces a continuous strand of silk that can stretch up to 1.6 kilometers in length. This remarkable feat of natural engineering marks the beginning of cocoon formation, a critical stage in the silkworm's life cycle and silk production. The silkworm starts by finding a suitable spot to anchor its silk. It then begins to move its head in a figure-8 pattern, extruding silk from 2 glands beneath its mouth. As the silk comes into contact with air, it solidifies, forming a strong, continuous fiber. The silkworm wraps this thread around itself, layer by layer, gradually forming a protective cocoon. Timing is crucial in silk production. Farmers must harvest the cocoons at precisely the right moment. If they wait too long, the silkworm will transform into a moth and emerge from the cocoon, breaking the continuous silk thread and reducing its value. This delicate balance between allowing full cocoon formation and preventing moth emergence requires careful monitoring and expertise. The silk itself is a marvel of natural chemistry. It's primarily composed of 2 proteins, fibroin and sericin. Fibroin forms the core of the silk thread, providing strength and flexibility. Sericin, often called silk gum, acts as a protective coating and adhesive, holding the fibrin fibers together. This unique composition gives silk its characteristic strength, luster, and softness. Not all cocoons are created equal. Various factors influence cocoon quality, including the silkworm's diet, environmental conditions during rearing, and genetic factors. High-quality cocoons are typically uniform in shape, with a fine, even texture. They're denser and heavier than lower-quality cocoons, indicating a higher silk content. As we watch the silkworm spin, there's a palpable sense of anticipation. Each cocoon represents a significant investment of time and resources, from egg selection to mulberry cultivation to careful rearing. The quality of these cocoons will directly impact the final silk product, influencing its texture, strength, and market value. On average, a single cocoon yields about 1,000 to 1,500 meters of usable silk thread. When we consider that it takes up to 2,000 cocoons to produce just 1 pound of raw silk, the scale of silk production becomes truly mind-boggling. As the cocoons reach completion, we prepare to move to the next stage of the silk-making process. In our next segment, we'll explore the intricate world of cocoon harvesting and sorting, where skilled workers and advanced technology combine to select the best cocoons for silk production. You might assume that every silkworm cocoon is destined to become fine silk, but in reality, the journey from cocoon to fabric is far more selective. What hidden flaws could cause a seemingly perfect cocoon to be rejected? As we enter the bustling cocoon sorting facility, we're immediately struck by the sheer scale of the operation. Conveyor belts hum steadily, transporting an endless stream of silken orbs to the screening section. Here, a combination of advanced technology and skilled human workers tackles the monumental task of sorting through millions of cocoons. The challenge is immense, efficiently identifying and removing substandard cocoons from this vast sea of silk. It's a process that demands both speed and precision, as even small imperfections can significantly impact the quality of the final product. Workers move with practiced efficiency, their trained eyes scanning for telltale signs of damage or irregularity. But what exactly makes a cocoon worthy of becoming high-quality silk? The criteria are stringent. Inspectors look for uniformity in shape and size, as well as the texture and color of the cocoon's surface. Any signs of disease, pest damage, or premature moth emergence are immediate grounds for rejection. The weight of the cocoon is also crucial, as heavier cocoons typically yield more silk. While human expertise remains invaluable, modern sorting facilities also employ sophisticated automated systems to aid in the screening process. These machines use a variety of sensors and imaging technologies to rapidly assess cocoon quality, flagging potential issues for further inspection. This blend of human skill and cutting-edge technology allows for thorough quality control at the massive scale required by the silk industry. As we watch the sorting process unfold, a question arises: what happens to the cocoons that don't make the cut? While our research doesn't provide specific details, we know that rejected cocoons often find new life in other industries, ensuring that little goes to waste in this meticulous process. The importance of this sorting stage cannot be overstated. The quality of the cocoons selected here directly influences the characteristics of the raw silk produced, from its strength and uniformity to its luster and texture. By ensuring that only the finest cocoons move forward in the production process, sorters play a crucial role in maintaining the high standards that silk is known for. As the carefully selected cocoons move on to the next stage of production, we prepare to witness the delicate art of silk extraction. In our next segment, we'll explore how these chosen cocoons are transformed into the fine, continuous threads that will eventually become luxurious silk fabric. The journey from cocoon to thread is a delicate dance between tradition and technology. As we step into the reeling facilities, we'll discover how centuries-old techniques coexist with cutting-edge machinery, each playing a crucial role in creating the silk we know and love. The sheer scale of silk production becomes immediately apparent as we enter the reeling room. Baskets upon baskets of carefully selected cocoons line the walls, each representing thousands of hours of silkworm labor. It's a staggering thought. Up to 2,000 of these delicate orbs are required to produce just 1 pound of raw silk. The reeling process begins with a crucial step: softening the cocoons. Workers carefully place batches of cocoons into basins of hot water, which serves multiple purposes. The heat kills any remaining silkworms inside, preventing damage to the continuous silk thread. It also softens the sericin, the natural gum that holds the cocoon together, making it easier to unravel the silk fibers. This hot water bath has the added benefit of removing impurities and bacteria, ensuring the highest quality silk possible. Once softened, the real artistry begins. Skilled workers, often with years of experience, deftly locate the near-invisible end of the silk strand on each cocoon. This requires incredible precision and a trained eye, as a single misstep could break the delicate thread. In traditional hand reeling, these workers carefully draw out the silk fibers, combining multiple strands to create a single, stronger thread. Alongside these artisans, we see modern machinery humming away. These silk reeling machines enhance efficiency by simultaneously drawing silk from multiple cocoons, creating longer and more uniform threads. Despite the advantages of mechanization, hand reeling remains valued for its ability to produce more complex silk threads, often sought after for luxury items. As we watch both human and machine work in tandem, the first continuous strands of usable silk begin to emerge. It's a mesmerizing sight. Gossamer-thin threads, almost invisible to the naked eye, gradually accumulating on reels. These threads, when combined, will eventually form the basis of some of the world's most luxurious fabrics. The reeling process exemplifies the delicate balance between efficiency and quality that defines modern silk production. While machines can process larger volumes more quickly, the trained eye and deft touch of experienced silk reelers ensure that the final product meets exacting standards of quality and finesse. As our journey through the reeling facility comes to an end, we're left with a newfound appreciation for the complexity of silk production. The transformation from cocoon to thread is just one step in a much longer process. In our next segment, we'll explore the final stages that turn these raw silk threads into the luxurious fabrics we know and love. You might think that once silk is unwound from its cocoon, the hard work is done. In reality, those gossamer threads are about to embark on a transformative odyssey. How does raw silk evolve from its humble beginnings into the epitome of luxury? The answer lies in a series of carefully orchestrated processes that push the boundaries of both chemistry and artistry. Raw silk undergoes up to 15 different processing steps before it becomes the fabric we recognize. Each stage is a delicate balancing act between preserving silk's natural beauty and enhancing its luxurious qualities. The first crucial step is degumming, a chemical process that removes sericin, the protein coating silk fibers. Workers boil the silk in a solution of soap or alkaline substances, dissolving the sericin to reveal softer, more lustrous fibers underneath. With the protective coating removed, the silk is ready for dyeing. This process requires careful consideration of the fiber's chemical properties, as silk is sensitive to heat and pH levels. Many producers opt for natural dyes to maintain the integrity of the silk, while others use synthetic dyes for a broader color palette. The latter option often requires additional chemicals to fix the dye to the fabric, adding another layer of complexity to the process. As the newly colored silk dries, it's prepared for weaving. Different techniques create various types of silk fabrics, each with its own unique characteristics. Plain weave produces a sturdy, versatile fabric. Satin weave results in a smooth, shiny surface that's perfect for elegant gowns. Twill weave creates a subtle diagonal pattern, offering a balance of durability and drape. Throughout these processes, maintaining silk quality is a constant challenge. Each step introduces the risk of damage to the delicate fibers. Temperature, chemical concentrations, and handling must all be precisely controlled to preserve silk's renowned strength and softness. The environmental impact of these processes is significant, prompting a shift towards more sustainable practices. Some producers now use eco-friendly dyes and recycle water from the dyeing process. Others are exploring organic silk production methods that avoid harmful chemicals altogether. As we near the end of our journey, we see how each processing step contributes to silk's unique properties. The degumming process reveals its natural sheen. Dyeing showcases its ability to hold rich, vibrant colors. And weaving techniques highlight silk's incredible versatility, allowing it to be transformed into everything from delicate chiffons to sturdy brocades. The result of this complex dance of science and craftsmanship is a fabric that's truly one of a kind. As we prepare to examine the final luxury product, we're left with a newfound appreciation for the intricate processes that transform humble silk threads into the epitome of elegance. From microscopic egg to luxurious fabric, we've witnessed the remarkable journey of silk production. This process blends ancient techniques with cutting-edge technology, showcasing human ingenuity at every step. We've seen how careful egg selection, vast mulberry farms, and controlled rearing facilities lay the foundation for high-quality silk. The artistry of cocoon formation, meticulous sorting, and skilled reeling transform raw materials into fine threads. Finally, complex treatments refine these threads into the silk fabrics we cherish. As we reflect on this intricate process, it's clear that silk production is a testament to both tradition and innovation. The next time you admire a silk garment, remember the countless hands and advanced technologies that brought it to life. This journey reminds us to appreciate the complex stories behind the luxury items we often take for granted.